Example E, log base 6 of 36 equals 5x plus 3. There's actually two different ways to work this problem, and I'll show you both, okay? So in method 1, we are going to apply the arrow thingy, okay? So we know that this means 6 raised to this power is equal to this quantity, 36, okay? And then that eliminates the logarithm, and we are left with an exponential equation, okay, because x is in the power, okay? So how do we solve an exponential equation? Well, we need to have the bases on both sides be the same. The base on the left side is 6, but the base on the right side is 36. So we need to change it, okay? Remember, most of the time it's easier to change the bigger number into the smaller number, okay? So we need to rewrite 36 as a power of 6, okay? 36 is 6 squared, okay? So that's the right side. Left side, we're going to keep it with base 6, so nothing changes, okay? So now you have a power of 6 equal to a power of 6. The bases are the same. The only way that can happen, if this is a true statement, is if the exponents are equal. Okay, so we'll go ahead and equate the exponents. Okay, so now this is a really easy equation to solve. So just isolate x by moving the 3 over. Okay, so we'll get 5x is equal to negative 1. Divide both sides by 5. You get that x is equal to negative 1/5. Okay. All right, so let me go ahead and show you method 2. Okay, so I'm going to go ahead and just rewrite the equation. Okay, so for method 2, original equation is log base 6 of 36 is equal to 5x plus 3. Okay, you could have, or you may have when you first glanced at this problem, okay, you may have concentrated on the left side, okay, log base 6 of 36, okay, so let me come up here, okay, log base 6 of 36. Remember, if you're just staring at that left side, that is equal to a number, okay, so what is that equal to? Well, remember, I'm trying to figure out what power do I raise 6 to get 36, okay? So 6 to what power gives me 36, okay? And the answer to that is 2. So the left side of this equation, you may have just looked at the logarithm and said, hey, that's 2, without doing the arrow method, okay? And it would have gotten you to the same place that you ended up over here, okay? So then you would just, follow the same steps you just did a minute ago. So you would get negative 1 is equal to 5x, divide by 5, okay? You also get that x is equal to negative 1/5, okay? So either way you like, okay? If you didn't see this, okay, you can do the arrow way, okay? Maybe you didn't want to do it this way. Maybe you looked at this logarithm and immediately knew it was 2, okay? Whatever works for you. All right, part F, okay? This is an exponential equation, okay? At the end of the day, when you get the final exam, you're going to have all these types of equations. You have to know what you're working with. Is this an exponential equation or is this a logarithmic equation? This is an exponential equation. You do not see any logarithm in it at all, okay? It is exponential. X is in the power, okay? So what we previously learned in section 6.3 is that to solve an exponential equation, you need to make the bases the same on both sides, okay? The base on the left here is e, and the base on the right side is 13 because it's 13 to the first power, okay? So you would have to make the bases the same since they're not the same here, okay? So can you rewrite e as a power of 13? Can you rewrite 13 as a power of e? No, okay? So this is the first exponential equation that we've encountered where it's not possible to make the bases the same on both sides, okay? When that happens, you have to use logarithms to solve the equation, okay? This is what we're going to do. You want to isolate the exponential piece, meaning, isolate the base with the exponent, okay? It's already isolated here, okay? So now you're going to apply a logarithm, okay? So it doesn't matter which one you use, which base, as long as whatever you do to one side, you do to the other, okay? But remember, E has a relationship with natural log, okay? They undo each other. So natural log should always be used with E, okay? So what I'm going to do here, and watch what happens, I'm going to take the natural log of both sides, okay? Whatever you do to one side, you have to do to the other, okay? And I want to make it clear to you, the natural log belongs on the left, not the right. Remember, the natural log or any logarithm is something you do to a number or whatever quantity follows it, okay? So like, for example, okay, natural log of 13 makes sense, okay? But if you do 13 natural log, that makes no sense, okay? The logarithm always has to be on the left side. Otherwise, it makes no sense. Okay, so I used ln because it has a relationship with E. They're inverses of each other, okay? Took the logarithm of this side. Whatever you do to one side, you have to do to the other, okay? So what happens here, remember what we learned. If natural log and E are side by side, they cancel out and the power comes down as an exponent, okay? This is going to be equal to, nothing is going to cancel over here. Natural log of 13 is going to be the right side, okay? The natural log has to stay there. It doesn't disappear, okay? Natural log of 13, I just put that in the calculator for you, okay? It is a nasty decimal. You're not going to round it. You're going to leave it as natural log of 13, okay? All right. This is an example. Well, I'll tell you after. All right, so this is just a number. This, I think it was about 2.56, okay? You're going to leave it as natural log of 13, okay? So if this is just a number, how would you solve for x? Well, you're going to isolate the x, okay? So you're going to move the 1 over, okay? So we're going to get natural log of, or oops, I forgot the left side. We're going to get negative 2x is equal to natural log of 13, that quantity, minus 1, okay? And then we need to divide both sides by 2, okay? So that is your answer. Natural log of 13, that quantity, minus 1, all divided by negative 2, okay? That is the answer. There is really no way to simplify it, okay? This is an example of an irrational number. So, I mean, if you looked at natural log of 13, okay, when we did a minute ago, this is a decimal. It doesn't repeat. It doesn't, stop. Usually, if you've got a natural log in your answer, it's going to be irrational, okay? So remember what the directions said to give the exact answer. This is the exact answer where you don't have a decimal involved. And then it also asks for a decimal approximation correct to 3 places after the decimal point. So to get your decimal approximation, you would do natural log of 13, okay? Close your parentheses here because you're only taking the natural log of 13. Okay, if you don't close your parentheses, you would end up probably doing 13 minus 1. You would end up taking the natural log of 12, and that is not what you want. Okay, so it would be the natural log of 13 minus 1. Hit enter. That's the numerator. Divide that quantity by negative 2. Okay, and there you go. Okay, so the answer, if we rounded it to 3 places after the decimal, it's going to be negative 0.782. Okay, because remember the number after the 2 is a 4, so we're going to stay the same. Okay, so we're going to say that x is approximately, okay, when we're referring to an exact value, x actually equals that quantity. And then when you put in the decimal approximation, we're going to use the approximately symbol. Okay, so here we go. That's the approximation. Okay, so I'll even write that on here. This is the exact. This is the approximation. All right, so that's how it works. Okay, if you cannot, in an exponential equation, You cannot get both sides to have the same base. You have to get logarithms involved. Okay. All right. So here's example G, similar to part F. Okay. But the difference here is that, okay, so this is exponential, okay, not logarithmic, okay. Since it involves an e, there's no way you're going to be able to get the bases the same on both sides, okay. So like I told you, you need to first get the exponential part, the base and the exponent, isolated, okay. Remember what we did here, okay. We took the ln because then that would put ln and e side by side and they would cancel out. If you started this problem and you're like, okay, I'm going to take the natural log of both sides, okay, and you did this to the left side, okay, you can't cancel the natural log and the e here because they're not side by side. That 4 is in the way, okay? So what you're going to have to do is isolate the e to the x plus 1 first. You need to get it by itself, okay? So what you're going to do, let me write the problem here. If you read it to yourself, this is 4 times e to the x plus 1 equals 5. Okay, since you're multiplying this quantity e to the x plus 1 by 4, okay, to get rid of the 4, you need to divide both sides by 4. Okay, so we're going to get e to the x plus 1 is equal to 5/4. Okay, now the e is free. There's nothing in front of it. Okay, so you can go ahead. Like I said, there's no way to rewrite these two quantities, these two sides, to make them have the same base. Okay, so we're going to go ahead and apply the logarithm. Okay, again, use ln because this is an e problem. Okay, so take the logarithm of the left side. Okay, whatever you do to one side, you have to do to the other. Okay, so that's what you're going to do there. Okay, and then ln and e are side by side, so we're going to cancel them out. Okay, and then the exponent will come down. Okay, and natural log of 5/4 is going to be some messy decimal probably. Okay, so leave it alone. Okay, and then now you can solve for x. Just subtract 1. Okay, so the answer is x is equal to the natural log of 5/4 minus 1. Okay, this is the exact answer. Okay, and if we went and we put this into a calculator, we can get a decimal approximation for this answer. Okay, all right, so let's go ahead and do that. Okay, so we're going to do natural log of 5/4, close the parentheses there, okay, because that's what you're taking the logarithm of. All right, so there we go, and now subtract 1 from that. Okay, so it's going to be, if you round it here, it's going to be negative 0.77. This 8 will round the 6 up, so we're going to say x is approximately negative 0.777. All right, and we will continue with 2 more problems.